Good day, this is Mr. Max with Sankofa Mathematics. So today I am doing paper 4 that was written last year, 2021, by the grade 12. This was the last grade 12 paper that was written for learners who are doing extended. So this content is useful for grade 11 learners and grade 10 learners. You can still use this content. So I'm going to go through this question paper, and again I'll be uploading this question paper on my Google Classroom. You will see on the description below that you can download it, and also the one of the answers as I'm working them out for your preparations for the upcoming examination. So this paper, as I said, the content is very similar to what grade 11 should know. The only things that were added basically to the old syllabus and to the new one now is just matrices and set notations and Venn diagrams. Otherwise everything else is the same. Okay, so I'm just going to delve right into it. There's quite a lot. I guess you should get your calculator ready and you should work with me. Alright, so the first question says you are supposed to evaluate. So this one, you grab your calculator and then you make sure that you get the correct answer. Okay, so it says you should evaluate, so it's calculate the skills. So make sure your calculator is working perfectly. So you have got 2.571, and you should multiply that by 0 or just 0.4239 times 75.34. Good. Alright, and then you should give your full calculator display and write your full calculator display as it is there. Okay, so the answer therefore is 0.28307308258. Okay, so that's with 1 mark, full calculator display. People, do not truncate or round. It's only the second part that you're rounding. So now this part says you should give your answer correct to 3 significant figures. So the first non-zero digit, in this case the 2, becomes the first significant figures, then the 8 is the second, but the number is less than 1, so you cannot just write 284. You have to still keep it as less than 1, so it's 0.284. Okay, straightforward. 1 mark questions. Question 2. During 2018 or 2018, a swimming lesson at a particular school lasted 48 minutes. The ratio of time spent in getting ready, swimming, and getting dressed. Ready, swimming, and getting dressed is given as 1 to 3 to 2, as you can see. So find the time taken for the person to get dressed. So you're going to add the parts. You're going to say 1 plus 3 plus 2. That gives you 6 parts of the ratio. And the parts where the person gets dressed, that's the last part as the information is given. So that's going to be 2 over 6, and then you multiply that by 48 minutes. Of course, you can simplify as long as you get 16 minutes here as an answer. Part 2, right? Remember, you can always pause and check how I am getting to the answers. Part 2 says you are supposed to find the time spent on swimming lesson, giving your answer as a percentage. So if you look at your ratio, the time spent on swimming is 3 parts out of the 6, which is the same as a half. So you can simply say, well, 3 parts out of 6 is the same as a half. A half of 100%, well, that is just 50%. The total lesson time in 2019 is 52. Calculate the percentage increase from 2018. So the increase is going to be that 52 take away 48, and then you agree with me, it's 4 minutes. So the percentage increase therefore will be that 4 over the original one over 48, and then you simply multiply that by 100. Okay, so you're going to get a recurring decimal, 8.333 recurring. Of course, remember, the beginning of the question paper asks you to give your answers to 3 significant figures if they are not exact. Part C, the total lesson time in 2018 is 15% more than it is in 2017. So the moment I hear something more, so I know that I'm now having to add 15%. So that gives me 115%. Okay, so now we need to find 2017. So that is in the past. And in order for you to find 2017, you can actually, you know that this question deals with reverse percentages. But let us just write down so we can see. So in 2017, or 2018 rather, the person spent 48 minutes. In 2017, we don't know. But we know that this 48 minutes represents 115% more than what the person should do. So by looking at these equivalent fractions, you should see that the decimal over the denominator here should be less, because in 2017 it should be less what it is in 2018. All right, so from here you can cross multiply. All right, so I'll also show you where the idea of the reverse percentage comes from. So that's 115x equals to 48 times 100. And then what you're going to do after that is you're going to divide throughout by 115, and you see if you divide here by 115, this is where the reverse percentage comes in. Okay, so you therefore grab your calculator and you'll see you'll get an answer of, say, about 41.739 and so on minutes. But the question says you must give your answer to the nearest minute, so to the nearest minute it becomes 42. Part D, John knows that at present, so this is a totally different question, okay, although it's the same scenario of swimming. So now you're told that presently he takes 200 seconds to swim 100 meters, okay. In a year from now, so let us just look at what we have before I continue reading the statement further. So we have got the time and we have got the distance. So if we have to calculate the speed, then we are going to divide the distance of 100 meters by the speed, by the time rather, of 200 seconds. So this is 0.5 meters per second. So this is his speed presently. In a year's time from now, he have increased his swimming speed by 25%. Okay, so when someone increases his speed by 25%, that means you're going to say 100% of what it is now, I'm going to add 25%. Remember, in the exams, you're not supposed to write in this margin. Okay, so because it's for the markers. So let us find what is his speed in a year's time. Okay, in a year's time, it's going to be 125% of 0.5 meters per second. So in a year's time, if you punch that in, his speed is going to be 0.625 meters per second, which is, you can see, faster than what he have presently. So this one is the present speed. But they are not asking us to calculate the speed. They are now saying calculate the time he will take to swim 100 meters. Right. So what you know, in order for you to calculate time, you have to take the distance, which is still 100 meters, and you divide this distance by the speed. Hence, you had to calculate the speed here. All right. So I'll just go down so I can have some more space here to work. So the time, which is what is required in this question. So you're going to say the distance, which is 100 meters, and you divide that by the speed of 0.625 meters per second. Okay, once you do that, you're going to get 160 seconds. That is the answer we were looking for in that question, because it says calculate the time. So read it very carefully. Right, let's go to the next question. So question 3, still on number concepts. You must read this question very carefully so you don't get confused. The normal price that Andries charges per haircut is 45 Namibian dollars and has completed 30 haircuts in 1 week. Calculate the amount Andres earned in week 1. So in week 1, he charges $45 and he had 30 haircuts. All right, so that gives you a total of 1,350. Quite straightforward. So that's week 1. In week 2, he completed 45 haircuts. Please don't get confused. It's not $45. In the first part, it was 30 haircuts. So here it's 45 haircuts. But 2 of the customers paid. So if 2 of the customers pay, so we're going to have 43 customers, and the other ones, the other 2, they pay 25% less. All right. So the 43 customers, they pay the normal price. Okay. So these ones, they pay the normal price. These ones, they pay 25% less. In essence, they pay only 75%. So work out the amount each of the 2 customers paid for the haircut. So there are 2 ways you can do it, but you can go ahead and say, okay, 100%, take away 25%. Well, that is 75% because these guys are only going to pay 75%. So 75% of the normal fee of 45, the normal fee to pay for a haircut is $45. So now they are only paying $33.75. Ideally, you can also say, okay, wait, find 25% of $45, and that gives you something like $11.75, and then you subtract this from, 45, okay, in order to find the same answer like that one there. Part 2, calculate the amount that he now earns in week 2. So we know that 43 people, they pay the normal fee of $45. And we know that 2 people, they only paid $33.75. So you grab your calculator and you then work that out, and then you see, I hope you see that you should arrive at $2,002.50. Okay, so just grab your calculator and work that one out. All right. In week 3, so in week 3 he earns 1,710 Namibian dollars, and all the haircuts were done at the normal price. The normal price is the 45 Namibian dollar. Okay, work out the number of haircuts he has. So 45 times the number of people, which we don't know, we call it X, and he made 1,710. In order for us to find the number of people, you simply say 1,710. You then divide that by 45. So the number of haircuts in week 3 was 38. Right. So we are still busy with the 1,710. It says 2/3 of his week 3 earnings were used to maintain the equipment and appliances in the barber shop. The rest, and this is where I am coming, the rest here, since he used 2/3 to maintain the equipment and appliances, so 1/3 is representing the rest. So what is 1/3 of 1,710? And if you then calculate 1/3 of that, you realize 570. So what does it do with this? Well, he is investing this using compound interest. So you are now asked to calculate the interest. So in order for you to calculate the interest, you can go ahead and you can calculate the compound interest first. Like I have 570, which is what he's investing, 1 plus 8.5%, which is the rate, and he's investing that for 5 years. Well, since I'm looking for the interest, I must take away the principal again. Okay, so of course, whatever method, so the interest is equal to the amount, which is what this formula here represents, minus the principal, which is what the 570 represents. Okay, so just make sure that you answer the question. So again, you can go ahead and you can punch that in, and you should get anything in the region of $287.08. Good. That brings me to question 4. Again, if you say I'm too fast, please remember you can pause and then you can check as to how I work out these things by also trying to do them on your own. So here we're supposed to make y the subject of the formula. That means everything else should go and y should be on its own. So that's going to have by equals to minus ax minus c. So from here, it's very simple. You are now going to divide minus ax minus c. You're going to divide it throughout by b. Okay, that is how you make b the subject of the formula. Well, part B is an inequality. There are two ways that you can do this inequality, but I'm going to try something different, okay? Since we have got something in the middle, I'm going to try to work my way from the inside. So I have got my 15 here, less than, so that's minus 3x minus 6 if I multiply out that. So the idea here would be for me to isolate the x. So what I will now do is I am going to add, I'm going to add 6 to both sides. Okay, remember you can do it totally different than what I do. So you can do one part and the other part and then combine them later. So this is going to be 21 and this is minus 3x and this is going to be 39. So from here, the next step is I'm going to divide by negative 3 and divide by negative 3. So please, when you use this method, just be very careful of the negative numbers, okay? And since I'm dividing by a negative number, I am going to change this inequality sign. So I know that it is not something that you're familiar with, but we're going to get there. Negative 3 into that gives you negative 13, and negative 3 into that gives you negative 7. However, negative 7 is bigger than negative 13, okay? And this is read, if you read it nicely, so negative 7 is the big number, and negative 13 is the small number, so the inequality is correct when you read it like that. X is less than negative 7, and x is greater than negative 13. Of course, you could also use another way to do this and then combine the end result. Okay, you're free to try that method. The next question deals with algebraic fractions or equation because it says we should solve. So what you do whenever you have an expression like a denominator, you always put brackets and you always put brackets. So my method I'm going to use, I'm going to make the denominators common by looking for the LCM, and the LCM is nothing but 12. All right, so this is going to be over 12, everything basically over 12, and on this side, this is a half is nothing but 6 over 12. Okay, right, so here I'll have my 4, and I have a minus here, and I'll have my 3. So the bracket of this one here, because 4 goes in there 3 times, so remember I'm going to have 4, and then here is going to be x plus 2, and I'm going to have the 3 here is going to be 2x minus 1. Of course, now you can drop the denominators, because if the denominators are equal, then the numerators are equal. So that means 4x plus 2 in bracket minus 3, 2x plus minus 1 should equal to 6. Just be careful when you are getting to multiply out this with that, the sign changes. Okay, right, so if you then multiply out, you get 8x. My goodness, it's not 8 but 4x. Okay, so you get 4x plus 8 minus 6x plus 3, very important, equals to 6. So this is a linear equation. You should be able to solve this equation without struggling. So you've got 4x, take away 6x, that's minus 2x. 8 plus 3, that's 11, equals to 6. So you have minus 2x is equal to 6 minus 11. Of course, minus 2x is equal to negative 5. And then x, therefore, will be negative 5 divided by negative 2. And the answer is nothing but 2.5. Of course, you can always go back and substitute 2.5 into the equation to see that the left side is going to give you the right side's answer. Okay, so this is a 4-mark question again. You have got a quadratic equation and a linear equation, and you're supposed to solve them simultaneously. So since both of them is equal to y, then you go ahead and you say, okay, x squared minus 3x plus 2 is equal to 3x minus 7. So we equate them, okay? And since we are now dealing with quadratic equations, we should make sure that quadratic equations always equal to 0, okay? So I'm bringing everything that is on the right to the left, all right, so that I can let it equal to 0, and the signs obviously change as you bring the terms over. So now you have x squared minus 6x, careful here, negative 3 is minus 6, and then you have plus 9. All right, so you have a quadratic equation that can be solved. Now, if you are familiar with this, you realize this is a perfect square trinomial. That means x minus 3, x minus 3. All right, x minus 3, x minus 3 equals to 0. In essence, it's x minus 3 all squared equals to 0. Get rid of the square by taking the square root of 0. The square root of 0 is 0. So x minus 3 is equal to 0. Therefore, x is equal to 3. So you have the answer for x. Now, we need to find the answer for y. So in order for us to find the answer for y, we go back and take the linear equation. Don't take the other one. You'll still get the same answer. So y equals to 3, and you are going to put the value of x, which we calculated already, and the value of x was nothing but 3. So now you work it out. That's 9, take away 7, and 9 take away 7, that gives you 2. So your two answers therefore for x is 3 and y is 2. You can go back and you can see they already gave you a hint here that there's only one answer for x and one answer for y. Good. Part C. Determine the value of the rational number p for which that is equal to 3p, 3 raised to the power of p. Of course, you should use the laws of indices and make sure that you understand. So let me work with the numerator. So the numerator, if you multiply and the bases are the same, remember this is the power 1, you add the indices, so 1/4 plus 1 plus 2, all right, and you divide that by 3 raised to the power of a half. So remember, when you have the square root of something, the square root of a is the same as a raised to the power of half. Okay, and that should equal to 3 raised to the power of p. Of course, once you add these things on top here, you're going to get 3 raised to the power of 13/4. Okay, divide that by 3 raised to the power of a half equals to 3 raised to the power of p. Right, so on the left side, when you are dividing and the bases are the same, you subtract the indices. Okay, so you're going to subtract the indices. All right, and if you subtract the indices, you are going to get nothing but, I'm going to write it under here, you're going to get nothing but 3 raised to the power 11 over 4 equals to 3 raised to the power of p. Now, if the bases are the same, so you go ahead and equate, okay, the indices. So in this particular case, p will equal to nothing but 11 over 4, or anything equivalent to that. Question 7, my goodness, question 5 on page 7. So question 5 deals with arithmetic progressions, or progressions as it is. It's arithmetic because the question says the first 3 terms of an AP are 15, 13, and 11. The common difference, you can say this is term 1, term 2, term 3, or use u sub 2, u sub 1, doesn't matter. So in order for you to find the common difference, you're going to say term 2 minus term 1, for example. So in this particular case, it's 13 take away 15. So it is negative 2. The sequence, as you can see, is decreasing. So the common difference should be a negative number. Now they ask you to find the nth term. So the rule, so the first term, we use letter A to represent the first term, is 15. The common difference is negative 2. The formula is T sub n equals to A plus n minus 1D. Okay, so the 15 is going to be here, plus n minus 1, and our D is negative 2. Right, so we are nearly done. So you're going to multiply it obviously over. So you're going to have something like 15 plus 2 minus 2n. So eventually the final answer there should be 17 minus 2n. And that is the nth term, or what we call the rule. Right. They say find n if the nth term is equal to minus 183. So what you do is you take the rule that you got in our Roman 2, you say 17 minus 2n, and you let it equal to negative 183 because you're looking for the value of n. Okay? So minus 2n is equal to negative 183 take away 17. So it's going to be negative 2n is equal to negative 200, and n therefore will be negative 200 divided by negative 2, therefore n is 100. Right, I am seemingly looking like I'm rushing to the things. Remember, this is a 120 mark question paper, and you have in the exam, they had 2 hours and a half to finish this paper. They are saying find, or if the sum of the nth term, so the sum of the number of terms is equal to that. Remember, the formula for S sub n is nothing but n over 2, and then you have 2a plus n minus 1 times d. This is the formula. Right, so they say we are supposed to find the number of terms. We know that a is 15. We know that d is negative 2. Therefore, n over 2 in bracket 2 times 15 plus n minus 1, because we're looking for that, times negative 2 should give you negative 36. So from here, I'm going to multiply both sides by 2. So here I'm going to have, in the bracket, I'm going to have 30. Now, if you follow closely, remember, you are going to multiply out this negative 2 over there. So you're going to have nothing but positive 2 minus 2n equals to negative 36. Multiply that by 2 in order to clear this fraction. So you're going to have 32 minus 2n. Okay, the n is still there. It didn't disappear. Sorry. Okay, so we're still going to keep that in brackets. Is equal to negative 72. Very close. So you see this is becoming quadratic, and you need to solve the quadratic. Hence, it's 5 marks. So I'm just going to move to this side. So I have minus 2n squared plus 32n is equal to negative 72, right? You can now go ahead and just make this a bit easier by dividing by negative 2, okay? If you divide, you're going to get n squared. Now the sign will change because you're dividing by negative, okay, equals to 36. All right, so quadratic equations, they should always equal to 0, okay? Now, again, you can use the quadratic equation formula, or you can factorize. Of course, I'll try factorizing because I know the two numbers multiplied to give you 36. They should be nothing but 18 times 2. So it will be n squared minus 18n plus 2n minus 36 is equal to 0. Okay, again, you can use the quadratic equation formula. From here, if I take out common factor n minus 18 plus 2, and then you're going to have, okay, that should be a bracket. So let's just correct that. So this is going to be 2 plus 2, and then you have n minus 18 here equals to 0. From here, you have n plus 2, or n minus 18 equals to 0. And if two things equal to 0, it implies that one or the other should equal to 0. Okay, so from here, you can actually go ahead and solve. I'm just going to write it under here before I take my answer. So one answer here, n is equal to negative 2. Well, I can't use this answer. This one, I am going to reject it because we're looking for number of terms, and the number of things cannot be negative. So n equals to 18. Therefore, to answer the question, the sum, find the number of terms, we say it has got 18 terms. Should be a positive number. Okay, number of things can be negative. Okay, it's a lot of work, and you should be familiar with your formula, and you should not mess up. Good. Question 6. There is a straight footpath of length 140 meters, as you can see, from point A to B. The 2 points are also joined by a railway track. in the form of a circular arc. It's not a semicircle, please. Circular arc, because this thing is a sector. Center is C, radius is 120 meters, as you can see in the diagram. Show that angle ACB is equal to 71. So it's this angle here. I'm just going to maybe use theta to represent this angle. Okay, so the cosine rule, and I hope you're familiar with the cosine rule. Cos theta is equal to 120 squared plus 120 squared minus 140 squared all over 2 times 120 times 120. Please make sure that you are familiar with the cosine rule so you don't make a mistake. And use your calculator. So this is cos theta is equal to, well, if you do this and you work it out on your calculator, you're going to get nothing but 23 over 72, right? So since we are looking for an angle, so we're going to then take the inverse, and you must make sure your calculator is in degree mode, okay? So theta is going to be the inverse cosine of 23 upon 72, okay? So when you grab your calculator, and you will now say, okay, let's clear that, the inverse cos, shift cos of 23 upon, what is it, 72, okay? You close that bracket, and then you get the angle, and you see the angle is 71.370, which to one decimal place is going to give us what is the required. All right, so theta is equal to 71.3706 and so on and so on degrees. Therefore, angle ACB, the angle there, is equal to 71.421 decimal place. Okay, so we have proved and we have arrived at that. Now they say calculate the shortest distance from C to the footpath. Now if you go back to the diagram, C to the footpath, it means it should be a perpendicular line. Okay, so if I say, for example, draw. Now let's not make that. Let's make it a solid line. So if you draw, extend it a bit. So it's not to scale. So let's say something like that. Okay. So no, it's horrible looking, but you get the idea. So this is 120 here. That's 120 there. That's 140 there. So what they are looking for, the shorter distance from here to there. Of course, in order for you to find that, you are going to have you have a right angle triangle, which you can work out if you want to. So the shortest distance there, perhaps if one were to look at that, it will be triangle like that. This is going to be 70 because it's half of 140. This is 120, and we are looking for this distance, x. So you can use Pythagoras. So you say x would be the square root. You're looking for a short side, and because you're looking for a short side, you're going to subtract. So 120 squared minus 70 squared. Okay, and this gives us 10 root 96, which is about 97.4679 and so on. So 97.5 meters. Of course, there are many ways that you can do this. You look at this triangle. If you were looking at this triangle, you could also say, well, I have a different way. I go and I say, okay, here's my triangle, for example, and I know that that's 90 degrees. I know that this angle here is 35.7. Where is it coming from? It's half of our previous angle that we calculated, half of 71.4. Half of that, because remember that triangle was for something like this. All right, so half of that gives us this. You can also then calculate this angle if you want to by subtracting this from 90, because the angles here should be complementary, 54.3. Whatever you do, you know this distance is 120 here. You know, now you can use your ratios in order to find that. So I'm just going to write the possible things that you could have done. on this side, and you will see that it will come to the same answer. So you could have used the sign, and then you use the sign of 54.3. Sine of 54.3 is whatever is opposite. In this case, you put x over the hypotenuse of 120. Someone else can use the cosine, then you use the cosine of 35.7, and that is x over 120. Cross multiply, you should get to the same answer, to 3 significant figures. Right, now they want us to calculate the area of the triangle. Now, again, you have got so many ways that you can do this. Remember, the triangle, if you have got all 3 sides, this side here was 120, 120, that was 140. We know this angle here was 71.4. So you can use the formula A equals to a half multiplied 120 times 120 times the sine of 71.4. Okay, so you have got a half times 120 times 120 times the sine of 71.4 degrees. That gives you 6,823. Okay, so it is 6,823. Well, you get 0.932 and so on. Remember, they are going to take anything correct to 3 significant figures. All right, so the 3 significant figures, this is like 6,820. Anything in that range to 3 significant figures. Okay, that's one way that you could do it. You can also use the general formula where you say a half times base times height, because you know what the height of the triangle is. Okay, so if you know the height of the triangle, you could also use that formula in order for you to find the area of that triangle. So you can go and say half times the base of 140 times that height that you've calculated. That will also give you the same answer in the range. Now they want us to find the area of sector ABC. So this is the whole sector, the whole thing here with the triangle with that sector there. So you are finding the area of the sector, and it is a part of a circle. And the formula to you're going to say, okay, to find the area of a sector, remember it is the angle over 360 times pi r square. Okay, so in this particular case, our angle was 71.4, and we put it over 360, multiply that by pi, multiply that by 120 square. Okay, so you go ahead, you grab your calculator, you work that one out. You should get anything like 2,856 pi. I'm just giving my answer in terms of pi, or anything within that range. All right, or you can say, if remember, you can calculate it 8,972.388 so on square meter. Okay, as long as the answer is within range, you will get the same, or the same marks. Then the shaded area, so you have the area of the triangle now. The area of the triangle is 6,820. We have the area of the whole thing. So in order to find the shaded, we just subtract the 2. So you will be saying the area of the shaded part was that going to be the 2,856 pi, or this 8,972. You take away 6,820, okay, and you punch that in your calculator. You should get something like 2,149.635 and so on. Now the answer will be any range between 2,100 and so I'm just going to say 1, 2, 3, so 2,150. Okay, anything within that range. So the acceptable answer for this, they will give you an answer in the range of 2,146 to 2,152, because it all depends what value of pi you are using and stuff like that. Okay, that was quite a mouthful. Let's go to question 7. So we have got a graph, and we are asked to complete the graph. So you grab your calculator for this, just to make sure you don't make a mistake. So you can say 2 raised to the power, x here is -2, so -2, that's nothing but a quarter, or 0.25. So it's 0 0.25, but we are working with graphs, so I'm going to have 0.3 here. Just in a minute I'll show you why. And then you go back and you put 1 there, because -1, you get a half, which is 0.5, so that's 0.5. It's better to give the answers here as decimals, and then you get 3, well, nothing. 2 raised to the power of 3 is 8, so you have got 8 here, and you have got your 3 marks. Okay, so you must remember all of those, and now you are ready to plot. So the first one, they say, be familiar with your scale also. Okay, so you see that this 2 centimeters here, each block represents 0.1, 0.1, because it's 1 divided by 10. So each block is 0.1, so no problem. Both the x's, they follow the same scale. So we go and we are now going to complete. So they are saying when x is -2, we got to 0.3. So that would be like 0.1, 0.2, more or less in that area there. When x is -1, well, we got 0.5. When x is 0, we got a 1. When x is 1, so I'm using my table, okay? When x is 1, we get a 2. So the exponential graph here. When x is 2, we get 4. So let me just go all the way up. So these values, I'm taking them from the table, okay? So when x is 2, y is 4. So that is going to be all the way here. And when x is 3, y is 8. So again, that will go all the way up right to that part there. So 3 will be, it's 2, it's going to be here. Okay, so let's make it smaller for us to see. Okay, that's way too small. Maybe a little bit more. Anyway, we are going to combine. Okay, we're going to combine this again. You see that the graph takes this shape. Is an exponential graph. Okay, so that's the shape the graph will take. Right. So remember, you have the liberty of taking your paper and turning it, and making sure that you use the inside of your palm. Right. I'm a bit out. Please do not use your your ruler to join those points. This is a curve. Well, mine is not as smooth because it's kind of tricky working on the software here. Okay, something like that. Okay, I will show you the other graph that I have on in a minute. Okay, so more or less something like that. So your graph will be something like that. Okay, all the points should be plotted, and just to give you an idea how this is marked, and very important that you understand. You now realize we have plotted 6 points. Okay, so you have plotted 6 points, so you get 2 marks for plotting all 6 points. You get 1 mark for plotting 5 points. Okay, so anything if you less than that, no mark for that. And then you get, for the smooth curve, you get 1 mark for a smooth curve. So you should not use a ruler. That's how the 3 marks are calculated. Okay, so the question carries 3 marks, 2 marks for plotting all 6 points, 1 mark for the curve, and then you get 3 marks, as you can see there. Right, the next question, so we're going to come back. Draw a tangent to the curve at x equals to 2x, 2 to the power x, so at x equals to 1. So here, at x equals to 1, here, we should draw a tangent. Now, yeah, well, of course, if you were doing AS level or higher level, or you know exactly, I'm just using this to have an idea, but of course you're not allowed to use this type of calculator. So when I differentiate the function, this is what I'll do, and it can give me the gradient at x equals to 1. I get 1.38436. So I know my answer should be in the region of 1.4. Okay, so Well, it's kind of something I do if I know what I need to find. I can obviously differentiate that without using the software, but you don't have the luxury with the software. So you want to draw a tangent. It should just touch this point. So I normally suggest to students, maybe start from that point. Okay, use your ruler, and then you see where you go. Okay, um, perhaps you can change the color. So it should just touch. You can start anywhere. It should just touch that point. So it will be like an estimate. Okay, so in order for you to calculate the gradient, so you will be taking, let's suppose you use any point that you have from here, maybe all the way up to here. Okay, so if I was to look at this, this is 1, the scale is 1, right? 1, 0.1, 0.2, 0.3, 0.4. Let's say that is about 1.4, the vertical distance, and I divide that with 1. Okay, when I divide that with 1. So you have got 1.4, divide that by 1. Okay, so you see I've got 1.4, which is more or less in the range. So my gradient line is actually perfect. So this is 1.4. It's just an estimation. Okay, an estimation. That is what this gradient is. So you draw that, and of course now you can answer this question. You say, okay, the gradient there is about 1.4. Of course, for this one in the mark scheme, they give you a range of answers because not all of us will have the same. Anything within that range, that is how that one's marked. So that gradient, that line that you drew, and 2 marks for the gradient. On the same grid, draw the graph of y equals to minus x plus 2. Okay, so let me just make a table for myself here. Okay, so the graph is y equals to minus x plus 2. So, well, let me see. If I make, because you only need 2 points to draw a straight line anyway, okay, so that will be the x value, and that is going to be the y value. Okay, so it's totally up to you which values do you want to use. So I'm going to use x values of minus 2, okay, and then I'm going to use maybe 3 to see. So if I substitute minus 2 into this formula, I'll get a 4. If I substitute 3 here, I get a minus 1. So I'm going to plot the points negative 2, 4, and the points 3, negative 1, and I'll join those points and they become a straight line. Okay, so negative 2, 4 is all the way, negative 2, 4 is all the way up there. The other one, as I said, if I plot it, it's 3, negative 1, and 3, negative 1 is all the way down here. All right, so now that I have my 2 points, I can make my graph a bit smaller, just so I can draw the line. Okay, so I will then use my ruler. So I'll join this point all the way with that point. Okay, so it's a little bit out. See if we can make it a bit bigger, a little bit bigger, maybe like so. And because I want to fit it in there, so I'm going to start over there, right to over there. Okay, more or less. So that will be my line, ladies and gentlemen. And you go ahead and label these things. Okay, so if I label this one is the function y equals to 2 raised to the power of x. Okay, and then the straight line of course is, the straight line is nothing but well, I'm just going to write it outside here. It was y equals to minus x plus 2. Okay, passes minus x plus 2. Is it minus x plus 2? Yes, it's cutting the y-axis at 2. Good. So that is 2 marks for, or 1 mark for doing that. 2 marks rather for doing that. Now they say solve graphically. So what this means is, where does the straight line that I drew now and the curve, where do they mix for x values? So you see that they meet here. all right, all the way here. So if you look nicely, you're going to have this point here, and of course that is 0.5. Okay, 0.5, and all of us should get the same answer for that question. So 0.5, 2 marks for my line, 1 mark for that. Explain why the y-axis is an asymptote to the curve. So what it means, the curve, this curve continues along here, but it will never pass the y-axis. Okay, the x-axis rather. The x-axis, the equation of the x-axis, the equation of the x-axis is y equals to 0. So my function is y equals to 2 raised to the power of x. So if y equals to 0, therefore I will say 2 to the power x equals to 0. So can we solve such an equation? So 2 raised to the power of x equals 0. You can't solve this, okay? Even taking log both sides. So this does not exist, and that is why the x-axis is an asymptote to the curve. Okay, right. Let's see if we go quickly back here, looking at what I have here. So it appears that this is a smooth curve. All right, this is more or less how the answer should be if you were to draw it nicely on your graph paper. Okay, remember this is a curve. It's not straight lines, it's a curve. And then you have the straight line that is drawn there, and then you have a tangent. The tangent will be slightly different, so your curve should also be very smooth, because it goes out too much, it will affect the tangent line, and then your gradient of the tangent line will be totally something else. Okay, practice with the graph paper and see if you can answer this question and draw smooth curves. Right, that takes us to next question. This question is on vectors. It says A, B, C, D, E, F is a regular hexagon such that CD is represented by X and DY, vector DY, DE equals to Y. Okay, so they say in part 1, we are supposed to find EC. Now, EC, that is, you're going from here against Y. So EC is ED plus DC. Okay, can you see that you are going against that? So it's minus y minus x. So in this particular case, you will say minus y minus x. Okay, don't forget to put those little squiggly line over there. EB, well, E to B. So look nicely at E to B. And I also want you to look at CD at the same time. See that E, B, and DC, they are parallel. So it means that if this here is going to be x, this is also going to be x. So when you go from E all the way up to B, you're going to go minus x, because we are going against. The arrow here indicates to you. So it's minus x, so the answer will be minus 2x. So it is minus x, so the answer is minus 2x. Clear? The next one, they say B to C. So it's B to C. And B to C, B to C. So let's just focus also on ED, right? So ED is Y, then this is also Y. So now you go from B to C, so you are going positive x against y. I hope you can see that, né? Because you're coming along here, that's x, and then you're going against that. So it's positive x minus y. Okay, right, this color, let's use something else. So it's positive x minus y. The next one is AD. Now, let's go and look at our AD. So from A all the way to D. Again, Just want to make sure that I can get my pen. Let me change the color back. So we are going from A to D. That is from A all the way up to D. Okay. So we know what BC is. BC is what we just calculated in the previous thing. Okay. We just calculate BC. So A to D will be twice our BC. Okay. So A to D, just look at your diagram nicely. A to D is twice BC. In this case, it's twice x minus y. And you can go ahead and multiply out. It's going to be 2x minus 2y. So it's twice BC. Right, part B, it is given that column vectors x is 2, negative 6, and column vector y is negative 1, negative 2. So you're supposed to subtract, you simply subtract the elements. So you will be saying, okay, 2 take away negative 1, and negative 6 take away negative 2. All right, so the answer on top there becomes a 3. The answer here is negative 6 plus 2, because it becomes a plus, which is negative 4. Please, it's not a fraction, and the answer should be like that. 1 mark for each correct component. Okay, so when you are looking at Roman 2, what they are looking for is the magnitude of the vector. So we use Pythagoras theory to calculate the magnitude of the vector. So we know already what the vector is. So we'll use Pythagoras theory. So we're going to say, okay, that is going to be 3 squared plus negative 4 squared. But of course, this is going to give you the root 25, and its magnitude is the it should be a positive value. Okay, the length of that. Right, so we get to question 9. Question 9, 118 commuters travel by taxi every day to work from town A to town B. Now I'm going to spend quite a lot of time on this little, or on this table here, rather, excuse me. The survey was conducted to find the distances traveled to work by the commuters. Their results are displayed in the table below. Now, if you add 3 plus 9 plus 34 plus 40 plus 32, you are going to get 118. You should get 118. Okay. So the question asks you for modal class and all those kind of things, but I want you to do me a favor. So you're going to have extra column here for class width, and we are going to have another one for frequency density. Okay, so we're going to add those values there. Suggest you do the same thing in the exam. Okay, so I'm going to put values in there, and on the other side I am going to bring in another table. It's called the mid-interval value. So again, I'm going to find what is the mid-interval value, because remember, these data here, you have to be a bit careful. Right, so what is the class width? The class width is like this. Class width here is 5, from 0 to 5, 5 minus 0, okay? 5 minus 0, okay? So the class width here is 5. The class width here is 15 minus 5, which is 10. The class width here is 20 minus 15, well, that is also 5. The class width 40 minus 20, that is 20. The class width here 55 minus 40, that is 15. Okay, so let us look at something called the frequency density. And I'm just going to write it somewhere on top here so you can know. Frequency density. Frequency density is the class width divided, okay, no, let us just correct that a little bit, excuse me. Frequency density is the frequency divided by the class width. So we're going to use that, and we're going to calculate the frequency density for each one. There's going to be a reason why we do that, okay? So I'm going to find the frequency density, divide that by the class width. So we are going to say for the first one, the frequency density, the frequency is 3 divided by the class width, which is 5. So that gives me 0.6. The second one, if we do the second one, we're going to have 9 divided by 10. Well, that's nothing but 0.9. So that's 0.9. The next one, the frequency of 34, we divide it by 5, get 6.8. So the frequency is here. The frequency density sequence is 6.8. The next one, excuse me, the frequency is 40. Well, 40 divided by 20 is nothing but 2. And lastly, the next one is 32 divided by 15. It's about 2.13 recurring. So 2.1 more or less. Okay. Good. That's the frequency density. The mid interval, the mid values. I'm just going to write it here so you can know what mid value represent. Okay. Mid value is the beginning value like, for example, 0 or the 5 or the 15 or the 20 or the 40. Then you add it with the end value, okay, of the group, like 0 plus 5, and you divide by 2. Okay, so for example, if I want to find this one here, I'm going to say 0 plus 5, then I divide by 2. You get it? I hope you are with me, okay? All right, so we're going to find the mid values, very important, because this information is going to be useful. So in order for me to find the mid value now, I'm going to take 0 plus 5. Okay, let's just put it here. So it's 0 plus 5. That answer divide by 2. Well, this is 2.5. Then this is going to help us with when we are calculating the estimate of the mean. Okay, we don't know how many actual people in that class group of 0 to 5 kilometer. Okay, 5 not included. We know there are 3, but we don't know exactly what person went 4 kilometers. The other one maybe could have gone 3 kilometers. The other one maybe 0 kilometers. So we are finding sort of the mean there, the average there of everybody in that group. That's what this mid value actually means. So 5 plus 15, we say that these 9 people who walked between 5 and 15 kilometers, all right, they, if you divide on average, we say they then walked for like 10 kilometers. Okay, all right, so it's just the average for that particular class group. The next one, beginning value, remember 15 plus 20, beginning value plus end value, you find half of that. And there you say on average in this class 17.5, in this class group 17.5 kilometer. The next one is 20 plus 40, that is 60, half of 60, that is 30. Okay, the next one, the last one there, is 40 plus 55, and we take half of that answer, 37 or 47.5. So it's 47.5. So in this class, the average there is about 47.5. That's the mid value. This mid value is very important when we are calculating part 2, which is the estimate of the mean. Right, so for the first part, when they are saying the model class, and here's what I want you to see. Since the class widths are not the same, okay, the model class will be the one that has the highest frequency density. In this case, it is the class group of 15, that one 15 and 20. This is one, the one of the highest frequency density. If okay, let me say highest frequency density. If the class widths were the same, say all of them were 5, 5, 5, 5, 5, 5, the same width, the model class will be the one with the highest frequency. Then you come to the frequency. But since the class widths are not the same, you cannot go and say, the one here is 40 because it's the highest frequency. No, the class widths are not the same width. This one is 5, that's 10, that's 5, that's 20, that's 15. So if the class widths are not the same width, then you are looking for the one with the highest frequency density. Hence, I calculated the frequency density here. This frequency density is also going to help me to complete the histogram that you will find in this question paper. Okay, and the model class or the mid-interval values here is going to help me to find part 2, which says calculate an estimate of the mean distance. Now, we use the frequency density, and the way we do it, we say, okay, in the group between 0 and 5, that 2.5 is the average in that group. Okay, plus the group between 5 and 15, the 9 times 10, that is the mid-interval, plus next one is 17.5 times 34, plus the next one is 30 times 40, plus the last one is 47.5 times 32. That's the frequency. And you are going to divide all of this, okay, by 180. Okay, so the answer will just be a estimate. So you are going to get, if you punch this in your calculator, you'll get the number on top becomes 6,825. You're going to divide that, or it becomes 6,825 over 236, which gives you 28.91949, and so on and so on. So on average then, the estimate mean is everybody walked about 28.9 kilometers. I hope you get it. Okay, so it was very important for me to find the frequency density. It was very important for me to find the mid-interval values, because the mid values times the frequency, mid value times the frequency, and you add them all as you go along, divided by the number of people. This gives you the estimate of the mean. Okay, the frequency density, I'm also going to use it because in the next part we are given the graph, okay, and we are then asked to complete the graph, because they did the first one here. Now, if you look here, the frequency density is on the y-axis, the distance is here, the kilometers, no problem. The class width here is 5, and if you look at these, the value here is 0.6, because the 0.6, remember, that is our frequency density for the class width of 5 in the beginning. So you see this 0.6 that I have here is what we're going to put in there. So I'm just going to bring down my frequency density and my class width so that I can complete here. So I know, so I'm going to make this a bit maybe smaller for me to write the stuff down. So I know that, so here, just to, I'm going to have my class width. And remember, you're not going to write in the exam in this part, but I'm just doing it for the sake of having space. So the class width, the first one of 5, it was 0.6, and you can see evidently here it's 0.6. Okay, the next one was 10, and it was 0.9. So and the class width is 10, so I'm going to go from here 10 all the way up to here. Okay, and the next one, the class width was 5 as well, and that was 6.8. This was the model class. And the next one, it was 20, the class width, and 2, the frequency density, and the last one was 15 and about 2.1. Okay, so we are now going to complete our frequency or our histogram. Okay, so I'm just going to make my graph a bit bigger so that I can have my scales properly. Okay, so the second one, the interval is 10. The interval is 10, so that is going to be from here 5 add 10, so I'm going to end up here. And it should be 0.9. So 0.9 is just here below 1. You see that? Okay, so you grab your ruler. Let's hope. So you grab your ruler, then you have all the way up to there, all the way up to here. Of course, you can continue. The bars must touch, now. All the way up to there. Okay, all right. So this is the class interval that I have. So, and it goes all the way up to 0.9. Okay. Remember, 0.9 is here. Right, the next one, the class interval is 5, so, and it goes all the way up to 6.8, so it's going to be from this 15 here to 20, okay? This one here was 5, okay? So maybe 25, maybe 35, maybe 45, and maybe 55. So this one is going all the way up to 6.8. Okay, so we need to find where 6.8 is. So 6.8 will be 6.5, 6, 7, 8. 6.8 will be here, up to there. Okay, so again, it's going to be here. All right, should be right on top of that, and it's going to come down. I'll bring you to go meet. It's rather than downstairs there. Okay, remember you have the freedom of the paper in front of you, and then you can just draw your lines nicely, and you can also color in if you want to. Okay, so that is this one. So, well, you to color it in. This is what that one will be like. It goes all the way. Okay, frequency, the class width is 5, and this is the one, the model class group, because it's the one with the highest frequency density, and all the way up to there. Okay, so that one's the highest one there. The next one is 5. So from the next one here, from it's 20. The class width is 20, and we should get to 2. So from 20, it's 20. So it's going to be all this up to here, right? So if I have to draw a line, it's going to be 20 to 40, like so. Can you see that? And it should be 2, right, as indicated. Okay, you can play around coloring the stuff in if you want to. All right, I just want to show you how you're going to do this in the exam. These things, they can take time, but if you have drawn your bars, remember, different class width, they're not the same. The bars, they touch. There you go. Right, last one is 2.1. So 2.1, and the class width is 15. So 15, this one is going to be, that's 5, 10, 15. It's going to be up to here. And it's about 2.1. So it's about there. So 2.1. So it's going to be slightly above the other one. Oopsie daisy. Let's start again. It's just there. See? Okay, so I know what the software is doing. So let me start from here. Somewhere here. Okay, all right, it wants to be funny. Okay, it wants to meet its friend, so let's just play around with it a bit. Say, okay, it's going to be all the way here, but remember you're using a ruler, of course, and we're going to go down. Okay, good. It's not smarter than us, right? That's how that one is done. Okay, all right, so that is the last one, and our histogram, guess what, is complete, ladies and gentlemen. All right, from our table and everything there. Hopefully, as I'm explaining, you also get an understanding of how to do these things. But you remember, I had to do quite a lot of working in the paper, working out frequency densities, a class width, mid value, in order for me to complete this one here. All right. So again, I have the histogram. The complete one should be something like that. Okay, something like that. If you were to do it nicely in your graph paper. Okay, you can just shade it in with a pencil, all right, in the examination. Right, so you're going to have all these answers on my Google Classroom. Right, so that takes me to the next question, question 10. We are close to the end. I know this is very tricky. Express y log 2 minus 1 plus log 5 in the form of log 2 raised to the power of y plus a. Okay, so first of all, this is log 2 raised to the power of y using my power law. And 10 is nothing but log 10. I hope 1 is nothing but log 10. Okay, log 10 is 1. So minus log 10 plus log 5. Are we together so far? So when you're subtracting, so you're going to have log 2 raised to the power of y on top over 10, okay, plus log 5. When you're adding, you multiply the numbers. So this is going to be log to the power y times 5 over 10. All right, so I'm running out of space, so I'm going to go to the next one. Now, 5 over 10 is a half, so that's log 2 to the power y over 2, which is like 2 raised to the power of 1. Now, remember indices, if you are dividing and the bases are the same, what do you do with the indices? Yes, you subtract them, so it's log 2 to the power y minus 1, okay, because the bases are the same, so that's like 2 to the power y, 2 to the power y divided by 2 to the power 1 is the same as 2 to the power y minus 1, okay? So this is from indices. Okay, so definitely my answer is then log 2y minus 1. And that is what they were looking for, that question. So it's a combination of logs and also your knowledge on indices. Find correct to 2 decimal places, so this is totally something else. You are supposed to take log both sides, so you're going to say log 2 raised to the power y plus 1, put that expression in brackets, equals to log 5. Log 5 is the calculator value. Then use the power law, you say y plus 1 in front of log 2 equals to log 5. Next, you divide throughout by log 2, okay, because you want to isolate. So you're going to say divide by log 2. Log 2, remember that's a calculator value. So the answer becomes y plus 1. So it's y plus 1 equals to log 5 over log 2. I'm not working it out yet on my calculator. I'm isolating for y. So y will be log 5 over log 2, take away 1 because we're adding that. Now I'm going to grab my calculator, okay? So we have got log 5 divided by log 2, and then we're going to take away 1, okay? So we get 1.32 blah, 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 blah. So the question says you must give your answer to 2 decimal places. So just go back and make sure 2 decimal places, and the answer therefore is 1.32. Comprende? Hope you understand. Hope you get it. Right, question 11. So we have got a probability tree diagram. So what is it that you need to know? When we go along the branches, we multiply. So just along the branches, we multiply. We add the probabilities as we go down, okay? And one of the things in the column section, one of the things you should know that when the sum of the probability for each set of branch is always going to be 1. So if that is 1 over 3, this one here should be 2 over 3, because 1 over 3 plus 2 over 3 should give you 1, and that is what happens there. 3 over 3 is 1. You get it? Okay. So we are going to apply that concept now when we are doing the set of branches. So this one here is 1 over 5. So this one here must be 4 over 5. Okay, if you don't know how to find it, you simply say, okay, 1 minus 1 over 5 is 4 over 5. Because they should, when you go along like this, they should give you 1. Okay, that's what I'm saying. All right, they should give you 1 set of. So this one is 1 over 6. This one becomes 5 over 6. And your job there is pretty much done for 3 marks for that question. Okay, now for 1 mark, they say find the probability that it will rain in 2 consecutive days. Day 1 rain, day 2 rain. When we go along the branches, that means if we go in this way, we multiply. Good. So along the branches, we multiply. So the probability that it will rain, that means probability of rain in 2 consecutive days, it's going to be whatever that fraction was. So it's 1 over 5 times 1 over 3. Okay, so it's 1 over 5 times 1 over 3 it's 1 over 15. Okay, anything equal to that, so maybe a decimal, but 1 over 15 is pretty much okay. Some people, they go and write these things as percentages. No need. Okay, find the probability that it will rain the day after tomorrow. So that means the first condition will also work. Today and then tomorrow. Okay, so we'll use probability of rain. So I'm going to write it again. The one we've got, probability of rain, which we know is 1 over 15, plus, because we now also have to find the day after tomorrow. So the day after tomorrow, it means no rain, but the day after tomorrow. So it's probability of no rain and rain. 4 over 5 times 1 over 6. Along the branches, we multiply no rain and rain. So probability of no rain and rain, because the day after the next day is this one, the day after tomorrow. That is what's going to happen as we're going along, right? So I was now saying tomorrow is here, the day after tomorrow. So I'm looking for when it rains. So rain and rain. So it comes no rain and rain. Rain, no rain, rain. So 4 over 5, 1 over 6. You multiply as you go along the branches, and then you add them as we go along. Okay, so no rain was 4 over 5. So we're going to say, let's just get our pen back. So plus, so it's 4 over 5. And rain, go back, rain is 1 over 6. Okay, can you see that there? 1 over 6, all right? And now it's just for us to finish that. Okay, so grab your calculator and see what is it that you're getting. So we have got 1 over 15, okay, plus in brackets 4 over 5 times 1 over 6. Good thing it's 3/4, yeah. 1 over 5, is it? 1 over 5. 4 over 5 times that, you get 1 over 5. Anything in that region. You can also get 3 over 15, of course, anything that is equal to that. So this means or equal to. All right, 3 marks for doing that. Right, that brings me to question 12. Question 12 is the last question in the question paper. So I hope so far you have enjoyed it and it really works to your advantage. Coordinate geometry, points A and B have coordinates 1, 5, 3, 1. Okay, so that is the x value and that's the y value. That's the x value and that's the y value. So the midpoint, you add the two x values together. So 1 plus 3, half of them, okay, comma, 5 plus 1, half of it. 1 plus 3 is 4, half of 4 is 2, comma, 5 plus 1 is 6, half of 6 is 3. Okay, so that's the midpoint. The distance between A and B, well, the distance is, you use Pythagoras, so you're going to say, take the two x values, you say maybe 3 minus 1, square that, plus take two values. I started with 3, so I'm going to start with 1, minus 5, and you square that. Of course, you get the square root of 20, which you can also leave as 2 root 5. Or, ultimately, you can say 4.472, 3 significant figures. Okay, the equation of the perpendicular bisector of line AB. So first, we need to find the gradient of line AB. So gradient is delta y over delta x. That means take two y values, subtract them together, take two x values, subtract them together. We know that A and B, point A is 1,5, point B is 3,1. So the gradient therefore becomes, let's say 5 minus 1 over, start with 1 minus 3, that's 4, divided by that, it's negative 2. Okay, why is this important? Because the gradient of the perpendicular bisector of AB will be the inverse of that, which is 1 over 2, and that's negative, so that has to be positive. Because if you multiply the gradients of perpendicular lines, you should get negative 1 as an answer. So the gradient of this line you are looking for, the gradient is nothing but 1/2. Okay, so I'm going to go ahead and say, okay, y equals to 1/2 x plus c. We don't know why that perpendicular line. will cut the y-axis. But we know that perpendicular lines, they bisect each other. Means you have got a line and a perpendicular line, they cut each other in half. So we know the midpoint. So we have calculated the midpoint before. So we are going to substitute the midpoint, okay? We're going to substitute midpoint for x and for y. And then I can find the value of c. So that means I'm going to go ahead and I'm going to say, okay, so wait a minute. Right, just create space. My equation, y value is x, that's y, so that's 3 equals a half of 2 plus c. That's 1. 3 minus 1, that's only 2, so c equals to 2. So my equation is y equals to a half x plus 2. All right, if it was too fast, you can always go back and pause and also check out your books. All right. Now we have another line, CD. It passes through a point, but this line CD, it is parallel to line AB. Parallel lines, okay? Parallel lines. What can you tell me about parallel lines? They have equal gradients. So gradient of AB, we determine the gradient of line AB is C is the gradient of line AB was -2. Okay, from our work before. Okay, the gradient of that line was that over there. Is it clear? So the gradient of this line will also be CD. So gradient of CD is also -2. So my equation is y equals to -2x plus c. But what do we know? We are told that this line passes through this point, which means we're going to substitute that point for x and for y. And then I'm going to rewrite it in this form. Okay, good. Follow? So we're going to have y is 3, x is -2 plus c. Good. Let me use the space down here. So that is 3 equals to 4, negative times negative, okay, plus c. Therefore, c equals to -1, because if you put that 4, you get -1. So my equation is y equals to -2x minus 1. However, we want it in this form. So I'm going to bring everything over. So I'm going to have 2x plus y plus 1 equals to 0. Make sure that you get that. 2x plus 1 plus y equals to 0. Okay, that is the end of this question paper. As I said, I am going to upload this paper on my Google Classroom. You will see a link below. This is paper 4. The content is very useful, especially for those of you who have not done the last part of the syllabus, this statistics stuff, or the stats, histograms, and all these things. This is an opportunity for you to revise and prepare. So stand by for paper 2 of the same component. Remember, this is paper 4. Paper 4 of extended. There is also paper 2, 80 marks. This one is 120, the other one is 80 marks. I'll upload that one soon. And then you have now quite a lot. I put on the mock exam that my kids wrote at Caliber Private School, and I'm going to still put paper 1, which was out of 80 marks. And that means you should have now enough work for ordinary level. After that, I will start with the work on AS level that I'm going to upload until for the next 2 weeks. Have a good one.